In 1977, humanity launched Voyager 1. It is currently the fastest object we have ever built, tearing through the void at 38,000 miles per hour. That sounds fast. But if Voyager were headed for our absolute nearest neighbor, Proxima Centauri, it wouldn't get there in our lifetime, or our children's lifetimes. It would take over 73,000 years. The universe is simply too big and our rockets are too slow. But science fiction offered a solution: the warp drive. The ability to engage an engine, blur the stars, and cross the galaxy in days. For decades, physicists dismissed this as pure fantasy. Einstein's special relativity is strict. Nothing with mass can travel faster than the speed of light. To do so would require infinite energy. But perhaps we have been looking at the problem the wrong way. What if we don't move the ship through space? What if we move space around the ship? In 1994, a theoretical physicist named Miguel Alcubierre found a loophole in Einstein's equations. He realized that while objects cannot move faster than light, space itself can expand or contract at any speed it wants. It happened right after the Big Bang, and it's happening right now at the edge of the universe. Alcubierre proposed a device that creates a bubble of flat, normal space around a starship. The mechanism is elegant. The drive compresses the fabric of space in front of the ship, pulling the destination closer. Simultaneously, it expands the space behind the ship, pushing it away. Think of it like a surfer on a wave. The surfer isn't paddling, they are standing still on their board. It is the wave of water underneath them that is moving them forward. In this scenario, the ship is the surfer and space-time is the water. Inside the bubble, the ship feels no acceleration. A crew could cross the galaxy in a week without even spilling their coffee. Mathematically, it works. It doesn't break general relativity, but physically the concept faces immense challenges. Gravity is attractive. Mass, like the Earth or the Sun, bends space-time inwards. But to make a warp drive work, we need to do the opposite behind the ship. We need to expand space. To do that, we need something that exerts anti-gravity. We need negative energy. This brings us into the strange domain of quantum physics. In classical physics, energy is always positive, but in quantum field theory, there are hints that negative energy is possible. We see this in the Casimir effect. If you take two metal plates and place them nanometers apart in a vacuum, the quantum fluctuations outside the plates are stronger than the ones squeezed between them. This pushes the plates together. The space between them technically has a lower energy density than the zero of the vacuum. It is effectively negative energy. So the fuel for a warp drive isn't antimatter or dilithium crystals. It's a manipulation of the quantum vacuum itself. If we have the math and we have the quantum theory, why aren't we visiting Alpha Centauri yet? There are three massive obstacles standing in the way. First is the cost. When Alcubierre first ran the numbers, creating a warp bubble for a small ship required more negative energy than there is mass in the entire observable universe. Later calculations refined this down to only the mass energy of the planet Jupiter. Converting the entire planet of Jupiter into pure negative energy is currently beyond our comprehension. Second is the death ray problem. As a warp bubble travels, it would sweep up high-energy particles from space, trapping them in the shell of the bubble. When the ship arrives at its destination and turns off the drive, all those captured particles would be released in a single focused blast of gamma radiation. A ship wouldn't arrive as an explorer, it would arrive as a weapon, incinerating the very world it came to visit. And third is causality. If you move faster than light according to relativity, you are technically moving backwards in time for certain observers. A warp drive isn't just a spaceship, it's a time machine. And the universe tends to resist time paradoxes. It sounds like a dead end. But theoretical physics moves fast. Just in the last few years, physicists have published new solutions suggesting that by arranging plasma in specific microscopic structures, we might be able to create a warp bubble using only positive energy. no exotic negative mass required. The trade-off is that these positive energy drives might not be able to break the speed of light. But they could get us close, reaching 50% or 90% of light speed without the crushing G-forces that would normally kill a human crew would still revolutionize space travel. We often look at the sky and wonder if other civilizations are visiting us. But if the laws of physics are as stubborn as they seem, maybe nobody is warping around the galaxy just yet. We are still a Type 0 civilization. We are still learning how to crawl. The warp drive remains on the chalkboard for now. But the fact that the math allows it, that the universe has left the door slightly ajar, means that one day humanity might just figure out how to walk through it.